Okay, and keep in one folder. So kinematics and forces is basically one unit motion. Or we can separate. Sometimes teachers like to have together, sometimes separately, like different tests, but doesn't matter. We are trying to do quick review of everything. Okay, so let me know when you're ready.
I'm ready.
Okay, so I want to show you, so basically for each unit, we have some learning goals and success criteria. So for kinematics, so because it learns about, what we are learning about, how fast, how far, how long, so basically what happened to the object without checking the reason. So what happens to speed, distance, time when object moves. Okay, so in kinematics, we need to use basically formula to calculate unknown. And in dynamics, next unit, it's why it happens. Okay, so you need to show, so in 4 areas, knowledge, knowledge, understanding, thinking, communication, application, that you have idea what is about. Some technologies involved involve kinematic concept. Okay, so we are dealing with linear motion, uniform and non-uniform. Okay, so uniform, it means a long straight line with constant speed. So think about empty highway. Nobody's around, you're driving, no turns, no changing speed. Okay, so it's uniform. Non-uniform, when object changes speed, speeding up or slowing down or changes direction. So whenever object changes direction, we deal with acceleration. Remember you had yesterday some quizzes. So object moves with constant speed but turns around. So we need to include that it has acceleration, like centripetal acceleration, and it's more for grade 12. But to have idea, yeah, you have acceleration. Okay, so about knowledge. So conversation, product. Okay, what do you think? So can you identify all given area, given and missing information to solve problems related to kinematics? For example, you have some information about the object, like distance, speed. So can you find time when it's motion with constant speed? So remember, when object moves with constant speed, it's only one formula, distance equal speed multiplied by time. When object moves with acceleration, it's like a bunch of 5 formulas with acceleration. Okay. So when you read a question, you know what is given, what is required, right?
Yeah.
So I'm sharing this screen, but can you see this on Zoom? Just 1 second. Yeah. Okay. So what you can do, maybe you can put like little check marks. Okay, I will try to make screen a little bit smaller. Okay, and you know what? Like I will try to squeeze it. Okay, I want to fit on 1 page. Again, it doesn't affect your mark. It's just to see what you know, what you don't know. Okay, like this, and I will put on 1 page. Okay. On the top black bar, you see annotate. Okay, do you see this little pen? So if you move your pencil up, so you see annotate. Do you have it? So you will be able to, okay, I see your cursor. Yeah. Okay, so if you click on annotate, you will have on the left side some bar. And what I want you to do, just to put some check mark. Yes, no, and think about level. Again, okay, we are still in a process. So don't put like too low or too high. So I think like somewhere around this area. So can you put just check marks? Okay, so when you read information related to kinematics. So you know that if it's meter per second, it's speed, right? If it's seconds, hours, it's time. And when it's meters, kilometers, it's distance, right? So you look at the problem, you know what is where, right? Okay.
Yeah.
Okay, so you can put check mark. Okay, so yes. Oh, it goes into, wow, it's out of my screen. Hmm. Maybe you have different size. Look, I have only in that in the middle of the page. Like, can you try?
Here.
Because here, like, yes, no. Oh, okay. But you put level 1 struggling. Okay, so try to move a little bit to the right. Okay, yeah, this is good. Okay, I will try to raise check marks on the left side. Okay, here. Okay. Choose equation and formula. Yeah, so it's when the motion is constant speed, you know that distance equals speed by time. What about what is in a question? Identify areas. Okay, so it's also like, you know, units, you know, is it distance, speed, or time, right? Or if it's acceleration, meter per second, correct. Okay, so put your check mark also there. Okay, what about observation? You can conduct your research effectively about reliable sources of information in your own words. Also, if you need, yeah, sure, like put somewhere here, copy before submitting a rough mark. Yes, like when you read question, you understand that you need to organize in proper format, you need to write units and formula, you show complete solution. Yeah, so what is given, like what you have, like for example, distance, speed, if you need to get time, so you write time question mark, and then formula substitution, and you solve it, right? So you know the process of how to solve problems, how to convert between units. Okay, so you remember that in 1 kilometer is how many units? How many meters? So 1,000. Good. Okay. So you know that. And we will review how to change speed from one unit to another. Okay, so put it also check mark. You can give reasons. Okay, so reasons, we will keep working on it too, so not to worry. Yeah, so you can put check mark. And whenever you have assignments, yeah, you can complete on time, sure. The communications usually using proper units, using proper terms, and explaining what you're doing. Okay, so vocabulary, diagram, formulas. So it's basically whenever answers, it should be logical and in proper format. And cite sources using APA style. Okay, so basically about the style, if you're using some source to do some research, you just need to put from where it's taking and name. Yeah, so you know that. You can submit your work in a organized manner. Yeah, so whenever it will be some presentation, yeah, so you know how to do it. Yeah, so put check marks. And application, yeah, and we are keep working on it. So when you solve problems, yeah, you can apply concepts. You can discuss different devices, yeah, how to use in a car speedometer to check instantaneous speed. Okay, so just put it. Okay, and discuss high speed rails. Yeah, yeah, sure. Okay, just I will save. PNG. Yeah, and now we can check. Yeah, I think when I will move to this page, check marks will be shifted. Okay, I need to close. Okay, then I'm moving. Just in case I will save screenshots. Yeah, I'll share the screen now. Okay, just to go through key ideas, like what is in that work. So if catch, like you can see it, right? Do you want me to make it a little bit bigger?
Yeah, a little bit.
Yeah.
Good.
And we can make notes and then erase notes. Okay, can't change its position from 82 kilometers east to 56 kilometers west on it. What is the car's displacement? Okay, so concept here is displacement, it's vector that joins initial and final position. So if at first you was here, like 82 kilometers east, so east it's, for example, here origin, and now you moved to 56 kilometers west. Okay, so it's basically on the left side, west, 56 kilometers. West is negative 56 east. So basically you're moving from here to here. So you're moving west, right? And what is this displacement? So 82 plus 56. So it's, okay, so tell me how far we are moving. Yeah,
82.
calculator. So basically you add together those numbers, right?
Yeah.
82.
138.
Yeah, so 138, yeah. So 138 kilometers and direction to the left, it's west. Okay, so from initial to final position, so that length of the vector. How long does it take bullet to accelerate from rest to this speed if you have this acceleration? Okay, so how long you need to get time, right?
Mm.
You have velocity, you have acceleration. Okay. From rest, so initial speed is 0.
Mhm.
Okay, how long? So you need to decide like which formula to use to relate initial, final, speed, and acceleration. Okay, do you remember those formulas?
Not
What is it?
much.
Okay, so V final equal V initial plus acceleration multiplied by time. Okay, so we have everything except time. So it's basically we are rearranging equation for time. So how to rearrange? Move everything else to the left side. Whatever
Mhm.
was plus or minus, you move to other side with opposite sign, right? And then
Yeah.
what you have, AT equal V final minus V initial. So you see it, right?
Yeah.
Move. Now, how to get time? Both sides divided by acceleration. So it's like delta V, change of velocities over change of time. Change of velocity, 32 minus 0. It's like 32. And change of time, oh, how long? Okay, well, vice versa, time we need to get. It's just opposite. Okay, so time equal velocity over acceleration. Okay, and acceleration 125, 10 in power 5. Okay, so use your calculator to check how much it will be.
256,000. No, it
56.
can be 32 divided 1
Divided by 125, and it will be 25.6, and then you take from denominator 10 in power negative 10 power 5, you put on the top, so it will be negative sign. And now to write in scientific notation, so you divide base by 10, so you got 256, but second part, you need to multiply by 10. So multiply by 10, it means degree will be -4 now. So it's like very fast, and it makes sense. It's very fast. Yeah, 256. Okay, about sig fix. Okay, so usually we follow the rule of sig fix, what is important, what is not important. Okay, so about sig fix. Okay, so if you have all 5 digits, for example, 5, 3, 5, 7, some number, okay, meters. So all digits are non-zeros, all are significant for sig fix. If you have 0 inside, 3025. We count this. Okay, so for sig fig. Okay, so 0 between other numbers is important. Okay, so it's significant. We call it like sandwich situation. So it's like bread without what is inside is not tasty. So you need to have something inside. So we count this significant. Okay, if you have 0 after the dot, 352.03. Okay, so we have 0 between non-significant, between whole number and decimals. So we count this as important. It's like measurement was done very precisely. So 5 sig fig. But if you have number, for example, 200, without dot, it means maybe it's 167, maybe it's 180. Because no dot at the end, we count 2 sig fig. But if you have dot 200 points, like dot, it's 3 sig figs. Oh, sorry. First one is 1 sig fig, just to show that those 2 zeros are not important. Okay. Zeros in front, 0005. We don't count, they're not important. So 1 sig fig. Okay. So okay, idea. So if zeros, if everything is non-significant, everything doesn't have zeros, everything significant. If you have zeros in the middle, we count. Zeros at the end. So if you have dot, we count. If you don't have dot, we don't count. If you have zeros in front, we ignore them. Okay, the operations, when you add and subtract numbers, okay, for example, 5.03 plus 3. You keep the smallest amount of decimals at the end, the least precise. Like 3 is least precise. 5.03, it was done up to hundredths precision. Okay, so the smallest number that has less precision is 3. So final answer should have the least amount of decimals after the dot. So if it's a whole number, so less precise, we keep less precise at the end. If you multiply and divide, so it's like this one is for addition subtraction. So least precise. So least precise. Okay. For multiplication division, smallest amount of sig figs. Okay, for example, 2.5 multiplied by 3.51. Okay, first number has how many sig figs? They're all non-zeros, so we count both of them. Right, so 2 sig figs. And second number, how many sig figs are there, Mohammed?
What is sig fig?
Yeah. So
Like
all of them,
zeros?
no, it's like important numbers. So all
Three.
all are three.
Yeah.
Three sig figs. So for multiplication and addition, so final answer, you check on calculator, and then you check what is the smallest number, the smallest amount of sig figs, like number of the smallest amount of sig figs. So 2 sig figs, right? So when you enter this on calculator, so I will enter now. So 2.5 multiplied by 3.51. So 8.775. Okay, we don't need so many sig figs. So we check first number had only 2 sig figs. So we need to round to have only 2 sig figs, and we use rules of rounding. So to leave 2 sig figs, 8 and 7, you check what is third one. So it's number that is more than 5. So whenever you have 5 or more than 5, you round that value to the next one. So it will be 8.8. Okay, so final answer should have only 2 sig figs, and we round. So because on the third place, on hundreds place, you have number more than 5. So 87, you upgrade to 88. Okay, so most of the time we actually follow those rules, but sometimes when you multiply by 2, divide by 2, it's we ignore it, because when you divide by 2, like 2 has 1 sig fig, but from other side, if you have big value and you need to be precise, so you can sort of sometimes ignore some rules. Okay, okay, so here you had speed 32 meter per second, and acceleration has 3 sig figs. Okay, so 2 sig figs, 3 sig figs, and we did multiplication division. So if to follow those rules, it's better to have like 2 sig figs, the smallest value. So 2.56 you can upgrade, so it will be 2.6 multiplied by 10 in power negative 4 seconds. Okay. Next one, car company is performing brake tests. Car reaches speed and slows at such acceleration. Okay. How long does it take for car to stop? So to stop, it means speed is 0. Okay, so initial speed you have in kilometers per hour, but acceleration in meter per second squared. Okay, so shortcut how to turn from kilometers per hour into meters per second is divide by 3.6. Okay, how to see it? Okay, I can erase actually those sig figs. We don't need them anymore. So you got the idea. So add, subtract, least precise, and multiply, divide the smallest amount of sig figs. Okay, so 165. Kilometers per hour. I can show you long way and then shortcut. Okay, so in physics, we are using coefficient of 1 to turn from kilometers per hour to meter per second, like from one unit to another. Okay, so you want to get rid of kilometers. So you need to write kilometer on the bottom. And meters, we want to get meters. And now decide like how kilometers and meters are related. So 1 kilometer is 1,000 meters, right? So if you divide them by each other, it will be coefficient of 1. So when you multiply by 1, divide by 1, nothing will change. But what it will help us to do, to get rid of some units. We don't want to have kilometers. Okay, so kilometers will be gone. Right, we will have meters. Now we need to get rid of hours. Okay, to get rid of hours, you multiply by hours, and you want to get meters per second. Okay, so in 1 hour, 60 minutes, 1 minute, 60 seconds. So 60 multiplied by 60, 3,600, right? And then what you do? Divide by 1,000, divide by 1,000. That's why you see this coefficient 3.6. So 165 divided by 3.6 gives you meters per second. Okay, so those hours we cancel too. Okay, and 165 divided by 3.6, 45.8. Okay, so 3 sig figs, we'll keep 3 sig figs, okay, meters per second. Okay, so you had speed 45, final 0, acceleration given. Okay, time. So time equal, so actually the same formula we can use as above. So change of velocity over acceleration. So velocity is 45.8 minus 0, 45.8. Acceleration is 10.8. Okay, so around 4 seconds to stop, okay, realistically. That's why never to run in front of moving car. It takes time for them to stop. And the bigger speed, the heavier they are, the longer it will take for them to stop. Okay, 4.24 seconds. Okay, I just keep 3 sig figs because you have 3 sig figs here, 3 sig figs here. Okay, how far does the car travel when braking? Okay, it's several formulas that relates to motion with accelerations, like big 3 or big 5. Okay, so the easiest one, actually, average speed multiplied by time. You have time already, right? So distance equal v initial, it was 0. Oh, actually, v initial was some speed. Yeah, 45.8 plus v final. So car stopped, speed is 0, divided by 2. So it means like average velocity, then multiply by time. Okay, so 45.8. Yeah, so get your calculator, check how much it will be. Yeah, you're done, right?
Yeah,
Okay, did you get the same? 97.1?
of course.
Okay, good. Okay, next one. Okay, so some car merge with velocity, again, kilometers per hour, so we'll need to change into meters per second. So divide by 3.6. So 52 divided by 3.6. 14.4. You have acceleration, you have time. What is displacement? Okay, so another formulas for displacement. So initial speed time plus at squared over 2. Okay, so we have initial speed, 14.4, time given, acceleration given. Okay, so just plug and chug. Okay, I got 168.5, and actually we can round till 2 sig figs. Okay, 170. So 170 meters. You see, like 170, it has only 2 significant digits. 0, we don't count. So 17, so 170. Okay, and how to get final velocity? So velocity will increase. Okay, object is speeding up. So formula that relates initial final velocity, acceleration and time is that one. So V final equal V initial plus AT. So V final, we need to find initial 14.4. Acceleration 2.5, time 7.2. Okay, so check how much it will be. Okay, yeah. So to 2.4, and we have 2 sig okay, 32 meter per second. Okay, how to draw vectors? Okay, so you remember orientation, right? So what is up? What is down?
Up is north, down is south,
Good. And here, east, west.
east, west.
Good. Okay, so when you have this orientation, like most of the time in our textbook, you have angle between, but sometimes it could be in front or on the back. So northeast, or west south. Okay, those ones are confusing. This one is actually easier to understand. So at first you go north and then you go east by 45 degrees. Like try to think about holding a pencil. Okay, so you're moving up, 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 and then east is to the right. So you're turning by 45 degrees to the right. Okay, so here will be your vector. Okay, so size is the length of hypotenuse, really. Okay, so if you go, see, if you go north and then 45 degrees to the right, or if you go to the right and up, you will get to the same position. Okay, so basically what we are doing, we are making horizontal vertical components. So to get this hypotenuse, you can go to the right up, or you can go up and then to the right. Okay, and to resolve components, we are using SOHCAHTOA. I don't know, did you hear this expression? It's like abbreviation. How to get adjacent, opposite, and sides in right angle triangle. So sine is ratio of opposite to hypotenuse, cosine adjacent to hypotenuse, and tangent opposite to hypotenuse, opposite to adjacent. Okay, so we don't need really to resolve, but to have some idea that if you need to find components, we are using SOHCAHTOA. Okay, and size 650 meters. Okay, so usually you need to select a scale, like 1 centimeter is 100 kilometer, for example. So the length of this vector will be 6.5 centimeters. It's actually meters, not kilometers. Six, 50 meters. So basically the length of vector, 6.5 centimeters under the angle of 45 degrees to vertical to horizontal, because it's right angle, 90 degrees, divided by half, it will be exactly 45 up or 45 down. This vector, west, 30 degrees south. So west is to the left and then down, right? So
Yeah.
you move to the left and down, and this angle 30 degrees. Okay, so 3.5 kilometers. Okay. And size, okay, 3.5 kilometers. Okay, maybe to choose like 1 centimeter is 1 kilometer. So you have 3.5 centimeters, 3.5 kilometers. Okay, scale. Okay, basically here is just review how to scale them. Here, explain why using scale is not very effective. Yeah, because it's not always possible to follow the scale, and yeah, if it's very big distance or very small distance, it's like not the best way. Okay, how to get displacement vector. Okay, so here it's basically they have component horizontal and vertical, and you need to get resultant. Okay, horizontal is dx. It's like 642. Vertical 1.1 kilometer. Okay, so it's 100. Okay, 1, 2, 3. So 1100, so it's longer. Up. Okay, and displacement. So displacement, it's vector. Okay. Oh, here it's actually to the west. Okay, to the west is to the left, and up is north. Okay, when we add vector. Okay, so just quick review. Okay, did you hear about two methods how to draw vectors, like triangle method and parallelogram method? No, okay. You know what? I have here PowerPoint presentation. Just maybe quickly I will show. I attach vectors PowerPoint to the chat. Okay, and just I will stop share and share this PowerPoint. Okay. Do you see the screen?
Yeah.
Okay. Okay, so basically, vector represent magnitude and direction. So it could be force, could be velocity, acceleration, tension. Okay, so when we add vector, we can add them graphically or analytically, algebraically, basically. So when you add vectors tip to tail, so like this example, you have vector A, vector B. So when you add them, you join initial and final position. So initial, okay, it's moving by itself, right? Okay, so you join initial position of vector A and final position of vector B. So it's a resultant vector. Okay, so it's sum of two vectors. If you have subtraction of vectors, it means you add, so A minus B, you add opposite to vector B. So opposite vector, it's the same size, but opposite direction. So it's the same as in math, like 3 minus 2 is 3 plus negative 2. So the same size, but opposite direction. Okay, you can check it. Here, if you have three vectors added together, you do the same way. At the end of first vector, you make second vector. At the end of second vector, you make third vector, and then you join initial and final position. So graphical method can let you to add more than two vectors. So it's easy to use this tip to tail method, and it's easy to check right away if your algebraical way of solving problem makes sense. If you add opposite vectors like A and negative A, so result is 0. Like the same as numbers. 5 plus negative 5 gives you 0. Okay, so here example of subtraction. A minus B is the same as A plus negative B. So you make first vector A, the same side, the same direction. It's jumping by itself, I think. Okay, 1 second. Okay, you make first vector the same as A, and then minus B has opposite direction to B. Okay, so you continue from the end of vector A to add that vector B. And then you join initial final position. So it's a resultant of subtraction of those two vectors. Okay, so you need to consider the order. So it's important to follow. So first vector, then second vector in opposite direction, and then you join initial and final position. We don't deal with equilibrant. Okay, so here it's a reminder how to get opposite adjacent hypotenuse. So in previous grades, we're using Pythagorean theorem to get unknown side. So if you have two sides, how to get third one? So hypotenuse squared equal one side squared plus other side squared. How to get the angle? Use SOHCAHTOA. So what is ratio of sine? So sine of angle theta is like reference angle equal opposite side. So opposite is far away, divided by hypotenuse. Okay, so is it something familiar or is it something new?
New.
Something new. Okay. So sine.
Which the tan and cosine.
Yeah, sine, cosine, tangent.
Yeah, I'm very familiar with it.
Oh, so you're familiar. Okay. And here, if you have hypotenuse, like some vector, you can resolve into components using trig functions. Okay, so what is easier to remember? To get adjacent side, hypotenuse multiplied by cosine. To get opposite side, hypotenuse multiplied by sine. So opposite related to hypotenuse through sine, adjacent is related to hypotenuse through cosine. Okay, so that's basically it. Okay, so if, graphical method, tip to tail. Horizontal method, mathematically, you resolve into components. You have, for example, 2 or 3 vectors. You need to add them together. So you need to find horizontal component for each of them, vertical components for each of them, find resultant, then use Pythagorean theorem to get the length of resultant, and use inverse tangent to get the angle, so to get direction. Okay, here, for example, you have vector A, okay, and vector B. So angle with horizontal are given. So what you do for first vector, okay, it's jumping. For first vector, you find horizontal component AX, so it's hypotenuse, 90 units, multiplied by cosine of the angle. For vertical component, hypotenuse multiplied by sine. Then for vector B, so usually I prefer to use like table. So first vector, horizontal, vertical, second vector, horizontal, vector, then add all horizontal components together. So AX plus BX gives you some horizontal resultant. Then you add Y components together. For first vector and for second vector, you add vertical component. And then use Pythagorean theorem and SOHCAHTOA. Okay, so Pythagorean theorem, one side squared, because you will have one resultant horizontal direction, one resultant vertical direction. So one side squared plus other side squared equal hypotenuse squared. Take square root. Okay, it will be your magnitude. How to get direction? So look at those components. So shift tangent opposite to adjacent gives you angle. And you can write that your resultant is 99 units and direction east, so many degrees north. Okay. Okay, so don't worry about those abbreviations. We don't use those abbreviations. Okay, so graphical method is tip to tail. Algebraic method is using Pythagorean theorem and SOHCAHTOA. Okay, we are going back to vectors. Okay, so number 7. So we had horizontal component to the left, vertical component up. So another way how to add vector is parallelogram method, because tip to tail, yeah, it's like at the end of one vector, you add second vector, you add third vector, for example, and then resultant will join initial and final position. Okay, so that one will be resultant. But if you have 2 vectors, okay, let's use red color. Okay, from the same point, one to the right, one up. Doesn't matter which angle. So you can use parallelogram method to get resultant. So you started them from the same point, make a parallelogram. So opposite sides equal parallel. So a resultant vector, let's use green color, will join point where you started and that point far away. Okay, so if you have, okay, obtuse angle, let's try, okay, one vector that way, another vector that way. Okay, make parallelogram. So resultant vector from point where you started to opposite end. Okay, so resultant. So usually for resultant, we show arrow on the top. Okay, so why I mentioned this parallelogram method, because you have two vectors from the same point, or you can make them from tip to tail. Okay, so here horizontal component, here vertical component. So resultant will be from initial to final. Okay, this result. So doesn't matter which method you use for two vectors. So resultants will have the same size, the same direction. Okay, so here we are using parallelogram method. So shape is parallelogram, opposite sides equal parallel, and vector started from the same point. And this method is triangle method. So you started from the beginning, so you make one vector at the end of first vector, second one, and resultant joins initial and final position. Okay, so how to calculate resultant vector? Okay, because they're perpendicular, you see west and north. So you can use Pythagorean theorem to find hypotenuse and SOHCAHTOA to get the angle. Okay, I will erase. So you got idea, right? So tip to tail, parallelogram method. Tip to tail, parallelogram method. Okay, so to get displacement vector, let's use Pythagorean theorem and SOHCAHTOA. Okay, so here you resultant. Okay, so how to get hypotenuse? What we need to do? Pythagorean theorem. So you have horizontal side 642 and vertical 1100. Remember Pythagorean theorem: one side squared plus other side squared. Okay, so check how much it will be, and then find the angle. Okay, so angle will be here. So angle equal tangent minus 1, opposite 1100, and adjacent 642. Okay, so write those numbers. Okay, so how big is the angle? So distance and then angle. Annotate. Okay, so you will be able to write, right?
So tangent power minus 1 times 1100 over 692, right?
Uh,
Or the
okay, but it's here, right? So one side squared plus
uh,
other side squared. Okay, so using Pythagorean theorem,
it's gonna be the same thing.
uh, it should be bigger. Hypotenuse is always longer, right? Displacement vector, it's hypotenuse. So hypotenuse is the longer side. Okay, so plug on calculator, check how much it will be.
Is this 4 or 9? That's 4 or 9.
642 and 1100.
Okay. minus 53.
What is the length here? Can you write length and angle?
I'm lost.
When you put in your calculator how to get hypotenuse, what you put square root 642 squared plus 1100 squared, and it should give you 1274. I can round to a whole number. So it's 1274. And how we can check that it makes sense, because it's the longer side. So other two sides are smaller. Okay, so try on your calculator, does it work? So square root, and then like one number squared plus other number squared equal to, so you got it, right?
No, not much.
Um,
I'm getting the different answer.
okay, what you're getting?
For the first one, 1273.
Yeah, 73.6, and we
6.
can round, yeah, and we can round to whole number because it makes no sense to have decimals.
Okay, sure.
Right, so 3 sig figs 74, even if you round till 3 sig figs is 1270.
Okay.
1270, so it doesn't matter really. So here I want to say like how to get side lengths using Pythagorean theorem, and then how to get the angle. Okay, so this one you got. Okay, so you
Yeah.
just round and it's fine. And second step, how to get the angle. So SOHCAHTOA. So shift, tangent, opposite over adjacent, right?
Yeah.
Opposite, adjacent. Okay, what you're getting. So here you need to remember a trig function to use degrees, not radians. Okay, so find and write your angle.
Minus 7.
No, it's bigger. Check, you probably have radians. So how to check if you have degrees? Tangent of 45 degrees should be equal to 1.
Okay.
If it's not 1, it means you have radians.
It was radiant.
Yeah. Okay, so check.
I got smaller. 0.02.
No, it should be 59 degrees, 59.7, so it's like 60. Okay, check again.
Calculator.
So maybe you need to put in brackets. Some calculators don't get if it's fraction.
It's the iPhone calculator.
Oh, iPhone is not good. Cell phones
Yeah.
are lying sometimes.
Mm-hmm. I'll get one by tomorrow.
Okay, so I will write it's 60 degrees. Just... Okay, so resultant vector will have direction. Okay, so D equal 1274. Okay, so you go to the left and then up. To the left, it's west, and then 60 degrees north. Okay, so here, final. Describe, okay, speed, okay, yeah. It's important for technology, okay. For us, we are trying calculations. Okay, number 9.
Mhm.
You have velocity at the angle 35 degrees to horizontal, and find time of flight, range, maximum height. Okay. About projectile motion. Okay, so you know what, like I will, okay, I will stop just 1 second. Stop sharing. I'll save it. Yeah, what is interesting about projectile motion that we can deal with 2D problems. Okay. Okay, so let's see here. So if object is thrown into the air, it's under the force of gravity and path is parabola. So 3 types of projectile motion. Object is moving horizontally, drops down. Second type, symmetrical projectile motion. You throw the ball into the air, it will land on the same level. So initial final position on the same level. And third type, it's more complicated when you have object thrown from some height. So initial and final positions are not symmetrical. So key idea, so only under the force of gravity, there is no other forces. Application, okay, for example, a classical question. You have a car and your car was moving on some bridge and it was written speed limit on the bridge. 36 kilometers per hour. Car was found down on distance, okay, what it will be, 60 meters. And height was 40 meters. Okay, was the driver speeding or not? So it's basically if insurance company needs to charge this driver or not. Okay, so for projectile motion, whenever you think about object flying into the air, so horizontal component of velocity all the time stay the same. Okay, so you see Vx constant. So if you show the size of the vector, but velocity in vertical direction depends from gravity, so it changes. So for example, you throw object into the air, so initial velocity was big, you pushed it, then it gets smaller and smaller and smaller, and on the top, velocity in y direction is 0. So Vx is constant all the time, but Vy is getting smaller, smaller, smaller when it goes up, but it's getting bigger and bigger and bigger and bigger when it goes down. So, and on the same level, horizontal, velocity up equal and opposite. So for example, like somewhere here, if you compare velocities up and down here, you'll have the same size, the same direction, or the opposite direction. So the same size, opposite direction. Vx will stay the same. Okay, so for that driver problem, so if object is dropped on the ground, this horizontal distance we call dx, it's range. So it's different with math, because in math in grade 11, students are dealing with domain and range. So domain is set of horizontal values and range is vertical. So in math, but in physics, we call it range. So range is horizontal distance. So range was 60 meters. So horizontally, object moves with constant speed, vertically with acceleration. So if object was dropping for few seconds down, It means we'll be able to find what is horizontal speed and compare with speed limit. Okay, so if height is 40 meters and object is dropping down, so maybe it's broken bridge, maybe driver was speeding so high, like had big speed, so it dropped down. So first step, so we need to check how long it dropped down. Okay, vertical motion is like free fall. So when object is under the force of gravity, so it moves with acceleration, and distance equal v0 t plus gt squared over 2. Okay, so in vertical direction, when object is moving horizontally, vy equal to 0. Later, speed will be bigger and bigger and bigger down. Okay, so what we have, shorter formula. We can rearrange for time and check how long it took to drop down 40 meters. Okay, so to get rid of denominator, we can multiply both sides by 2. So fraction disappears. Now how to get time? Both sides divide by g and take square root. Okay, height of that bridge from the ground, from the river, is 40 meters. So twice 40. And we can count g round till 10 meter per second squared. Okay, so when you divide by 10, what you'll get? Square root from 8, 2.3 or something. .8. Okay, so 2.8 seconds. So car was falling down 2.8 seconds. The same amount of time, car was moving in horizontal direction. So horizontally, you have time, you have distance, that range, so you'll be able to get speed, because horizontally, object moves in projectile motion with constant speed. Okay, so 21.4 meters per second. Okay, and now we want to be precise to compare those two speeds. Okay, so how to compare speed limit 36 kilometers per hour and this speed 21.4 meters per second? What we can do? What do you think? So we need to have the same units. Right? So how to have the same units?
For what?
So speed limit is 36 kilometers per hour. And our driver who fell down in the river near the bridge had speed 21.4 meters per second. You see, kilometers per hour, and here meters per second. So how to compare what is bigger, what is smaller? So how to change them into the same units? Remember coefficient 3.6?
Kilometer is 1,000 meters.
Yeah, so we can change kilometers per hour into meters per second.
Yeah.
Or we can change meter per second
Or
to kilometers per hour.
to kilometers. Yeah.
Yep. So here you can divide by 3.6 and you will get meters per second. So 36 divided by 3.6, 10 meters per second. Okay, so speed limit was 10 meters per second, and our driver had 21.4. So what is conclusion? What is bigger?
21.
That one, right? So driver was speeding. Okay, so he will be charged. Okay, driver exceeded the speed. Exceeded speed limit. So it's easier to remember like life situation. So if somebody will be found down, okay, so how to apply projectile motion. So it's like first type of projectile motion, vertical component is 0. So it's not under the angle. Whenever you have projectile motion under the angle, it's like more complicated steps. Okay, so you're dropping down. So at the beginning, Vy is 0. Every second, vertical component will increase, but horizontal stay the same. So because it takes the same amount of time like for free fall, like free fall, you drop object, it's falling down. It's also under the force of gravity, it's speeding up. But projectile motion, it will take the same amount of time to go down. It's like in from Pisa Tower, Galileo was throwing object, and what he found doesn't matter if it's heavy or light object, so they will land at the same time. It could be some discrepancy because of force of friction, air resistance, but theoretically we count, okay, time to go down is the same. So if you will find time to go down those 40 meters, we can find speed to pass this horizontal distance. So horizontal distance divided by time of flight gives you speed, and you compare with speed at the beginning. So if person was speeding up or not. And to have the same units, so here is like usually like 5 points question. So how long it will take? What is speed? Horizontal speed. Then relate speed limit and person speed. And maybe to make conclusion. Okay. For motion under the angle, so second type of projectile motion, whenever you have objects thrown under the angle, so first step, what you need to do, resolve into horizontal and vertical components. So Vx and Vy. Okay, so we had, okay, and then to count how long, for example, object will take to go up. So when object is on the top position, then it doesn't go further, it falls down. So velocity at that point equal to 0. And we can calculate how long it took to go up by using those formulas for accelerated motion. V final equal V initial plus GT. Okay, to remember about the sign. So in math, we're stuck to the right and up positive, and to the left and down negative. In physics, it's up to you where you will choose direction. So you can choose direction up positive. So in that case, so velocity final, okay, 0. Initial velocity will have direction up, so positive. Okay, for example, here is like, let's count 10 units, angle 30 degrees. So vertical component equal 10 multiplied by sine of 30. It's 10 multiplied by 1/2. 10 divided by 2 gives you 5. So 5 meters per second. Okay, G is down. It's always towards to the ground. So minus 9.8, or often we count as 10 to make it easier. Multiply by time. So how to rearrange for time? Move to other side. So 5 equal 10. So we can round till 10. So 10G, 10 time. Now how to get time? Both sides divided by coefficient in front. So half of second, it will take object to go up. Okay, if question will be how long it will take to land back to the ground. So we use this idea that to go up, half of seconds, to go down will be the same time, because parabola is symmetrical and we ignore any other forces. Okay, so half a second up, half a second down, so twice 0.5 is 1 second, whole flight. Yeah. So projectile motion. And projectile motion third type, okay, it's more complicated in textbook. So you have that new Nelson edition. So they have example on the left side of the textbook when somebody from the building throws object up under some angle, and then they're asking total time of flight, horizontal distance, vertical height was given. Okay, so what you do in those situations, you solve using quadratic formula. So with discriminant, and you will get time of flight. So what is tricky there? So when you solve for time, you will have also negative root. So negative root, it's when it didn't happen yet. So you ignore that solution. So only from time equal to 0, here, for example, time, and here height. So theoretically, when you get that negative root, you ignore it because it's not possible. Okay, and how to solve quadratic equation? Use quadratic formula. If it's easy way to solve, you can use factoring. Okay. Let's go back to our question. Yeah, projectile. So you have idea. Okay, so I wanted to show for kinematics typical questions. It's in worksheet 07, kinematics review part 2. Okay, just 2 questions. Okay, I will stop share, copy questions, and open in Word document. So it was questions about rugby players. Just I will copy. Okay, Mohammed, do you see it?
Yes.
Okay, so whenever you have any physics question, try to imagine or make a little sketch. Okay, so you have two rugby players running towards each other. Okay, one runs here, another runs towards. One is bigger, one is smaller. Sort of. They are 37 meters apart. Okay, distance between them, 37 meters. If one of them accelerates from rest, okay, so V initial 0, acceleration 0.5 meter per second squared. Other was moving, so you had some speed and keep constant. So it means motion with constant speed, motion with acceleration. How long before they crunch together? So when they will meet each other, so they will meet somewhere here, maybe it will be happy end, maybe sad end. Okay, how hit. Okay, so what you do in those situations, you relate distance that one person run plus distance of that another person run equal 37. So it's like classical problem. So distance for the first person. So this player moves with acceleration. Initial speed is 0. So V0t will turn into 0 plus at squared over 2. Okay, for first person. Okay, number 1. And here, number 2. Second person moves with constant speed. Which formula we can use for motion with constant speed? The shortest one. Speed by time, right? So velocity multiplied by time. Okay, so let's plug numbers. So at squared is 0.5. We don't know how long, but we know they started at the same time, and it will be the same amount of time for them to run to crunch together. Okay, so speed is 3.1 multiplied by t. Okay, if you add them together, it's 37. So basically, you will make quadratic equation, and you solve that quadratic equation. Okay, so whenever you solve, you try to make it more simple. Okay, what is easier? You have 1/2 divided by 2 is basically 1/4. So if you multiply everything by 4, you will get rid of all those coefficients. It will be just 1. So t squared plus 3.1 multiplied by 4, 12.4. And 37 multiplied by 4. So whatever you do to one side, you do to the other side, right? 148. Okay, when we solve quadratic equation, we have like everything on the left side. So you need to move 148 to the left and then use quadratic formula. Okay, so A equal 1, B is negative 12.4, C is negative 148. Okay, so quadratic formula, negative B, so it's opposite to that number, 12.4, plus minus square root from discriminant, b squared, minus 4ac. A is 1, you don't need even to write, and c is negative 148. Divided by 2a. Okay, so under the root, whenever you have negative number in power 2, it will be positive. So 12.4 squared. Negative multiplied by negative gives you plus. So plus 4 times 148. So 745.76. We can round after. $27.3. Okay, so what you do? So if you, okay, so one root when you add them. Uh, 1985, so approximately 20 seconds. So T2 will be negative, so we ignore it. Look, from small number, you take away big number. So it's less than 0, so ignore. Okay, so after 20 seconds, they will meet. Okay, approximately how far they will pass. Okay, because I rounded here, it will be slight discrepancy, but it's okay. Like D1, 0.5 multiplied by 20 squared over 2. Okay, 400 divided by 2, 200. 200 divided by 2, 100 me. Oi. I missed something. Seconds. Maybe it's fine. Okay, 400 divided by 2. 200. Yeah, it's a little bit too big. Yeah, it's still 20 seconds. Okay, I had plus, and now I had minus. Okay, that's why, third line. Plus, okay, negative, negative, negative. Okay, now it will be better. It's smaller time will be. -27 minus 12, 15. Yeah, and divided by 2, approximately 7 seconds. Okay, makes sense now. Okay, 27.3. .45. Okay, let's keep decimals. Okay, now how far did they run? So you can plug into formulas for distance, time. Okay, 745 squared. On calculators, you have even buttons like x squared, like when you have calculator. Okay, multiply by, okay, divide by 4 basically. 13.8, 7, 13.9. Okay, and D2, speed 3.1, multiply by times 745. 23.1. Okay, so this guy will run 23.1 meters. This guy 13.9. And if you check if it's true, yeah, so 37 meters they run. Okay, so it's one of the classical problems, and another classical problem when police is chasing the person. And they started from the same place or on some distance. I want to save. Yeah, so second question. So I will stop sharing and then copy and then share again. Just please come. Okay, so you see it, right? Okay, so two objects at the same place. So speeder and police car. Okay, so police is standing and speeder is passing by with speed too high, they think. A police car started to accelerate. Okay, so acceleration 3.6 meter per second squared from rest. Okay, when they will catch, it means they will meet at some point. Okay, so if you have like distance time graph, okay, so it looks like This speeder moves with constant speed. Police moves with acceleration. So remember yesterday we were checking graphs. So when it's accelerated motion, graph will be curve, and positive acceleration, so curve will go like that. So at this point, after some period of time, they will meet. Okay, it will not be happy meet because police will give ticket. Okay, so idea the same. So if they will meet, distance that they will pass will be the same. So distance that this car of speeder will pass will be speed multiplied by time. It's like d1. d2, distance that police will pass will be v0t plus at squared over 2. And initial speed was 0 because police was at rest. It was just standing on near the road. And then when it noticed that car had high speed, started to chase. So basically it's at squared over 2. So those distances are equal. So when they will pass, d1 equal to d2, right? So those distances will be the same. So we can write that speed of the speeder multiplied by time when they will meet equal at squared over 2. Okay, so d1 equal to d2. And then we can find time from there. And because you have acceleration in meter per second squared, so you change time 100 kilometers per meter into meters per second. Okay, do you remember how to change? What we do to that coefficient, 3.6? So from kilometers per hour into meters per second, you need to divide, right? Divide by 3.6. So 100 divided by 3.6. Okay, what you're getting? Tell me. I'm just checking in case if I'm losing connection. Are you here, Mohammed?
Yeah, I'm calculating.
Okay, yeah, okay. So 100 divided by 3.6.
Mm, 27.7.
And 7 you round 0.8, right? So 27.8 multiplied by time equal acceleration given 3.6 times squared divided by 2. Okay, whenever you have equations that you can reduce, try to do it like you see right away. Okay, it's easier to reduce that number. So it's 1.8 t squared. Move everything to one side. Okay, and when you look at this quadratic equation, what you see, A is there, B is there, but C is missing. Okay, so whenever you don't have anything plus minus, no C term, it's easier to solve using factoring. So you take outside something what is common for both of them. So you can take 1.8 t, then t minus, okay, 27.8 divided by 1.8. So you factor the coefficient. 15.4. Okay, so you know how to do it, right?
Can you do it again?
Okay, so you understand what was done?
The 15.4.
Okay, so we okay, so factoring and distributive property are opposite to each other. So if you take outside common term for first two terms, how to write what is inside of the bracket? So first term divided by coefficient 1.8 t gives you t. Then second coefficient, second term divided by coefficient 1.8, so gives you 15.4.
Yeah, okay. Now it makes sense.
And yeah, and it's opposite. Okay, you know, with small numbers, maybe it's easier. Just I will show small numbers. 3x squared minus 12x equal to 0. So 12 contains 3 and x. So it's basically 3 multiplied by x minus 3 multiplied by 4 multiplied by x equal to 0. So when we factor, we take something what is common outside of the bracket. So 3x belongs to each of them. What will be left? X minus 4, right? Equal to 0. So here we call factoring. If you use distributive property, like it's like sprinkles multiplied term outside by each term inside of the bracket. So here it's like expanding. So what you get? 3x multiplied by x, 3x squared. 3x multiplied by -4, -12x. Okay, so factoring and expanding are opposite operations to each other. Okay, so what we have here, product of some term and some expression inside of the bracket equal to 0. So we apply zero product property. Basically, when product of two terms equal to 0, when one of them or both of them equal to 0. So and or one of them or both of them. So it means 1.8 is not 0. So it means time equal to 0. At the beginning, when they were standing near their road light, okay, so time equal to 0. And then second one, t minus 15.4 equal to 0. It means after 15 seconds, they will meet. Okay. If question will be, how far did they pass? You just multiply the equation for motion. So object that moves with constant speed. So speed of that person multiplied by time, 15.4 seconds. For police acceleration, multiply by that time squared and divide by 2. Okay, and basically it will be the same distance. So it's the classical problem when objects are moving towards to each other. Like think about rugby players. So one distance plus another distance equal some value. And second situation, when they're moving from the same point, one moves faster with acceleration, it's police. It's like curved line, curve here, and speeder moves with constant speed, so straight line. Okay. How to show that police moves faster and faster and faster. It's like diagram that will show that after a while, yeah, they will reach each other. I will save screenshot. Okay, I can make a little bit smaller screenshot. Oh, no. Yeah. Okay, and I want to jump to forces. Because in forces free body diagram, I had like nice file there. Okay, just I will open. Forces review and forces free body diagrams. Okay, forces of friction key. Okay, this one nice. Okay, so what to remember about forces? So force is push or pull. We measure in newtons. The bigger force, the bigger vector. So when object is moving on horizontal surface, so we can have 4 forces. Okay, so if object is at rest, so force of gravity and normal force equal and opposite unless you push or pull on the object. If you're dragging with constant speed, object will move and forces to the left and to the right are equal to each other. Applied force equal to force of friction. If object moves with acceleration, you have imbalance of forces. Okay, so right before those forces, it's a like nice introduction. I hope you check textbook and try to read. So in chapter 3 and 4, basically about Newton's law. In chapter 3, so Newton's law, if forces are balanced, so F net equal to 0. So I can write and then erase. So F net equal to 0. So velocity is constant or velocity is 0. Okay, it means could be two situations. If forces are balanced, object could be at rest, not moving, or object could be moving with constant speed. And this law also we call law of inertia, we need to distinguish what is force, what is mass. So mass is not the same as force. So mass we measure in basic units kilograms in this system, and force we measure in newtons. So force is like force of gravity. It's how hard object is attracted to the earth. So mass multiplied by acceleration of free fall g. So when you move to other planet, g is different. So on earth, g is 9.8 approximately, slightly varies on different location, but it's 9.8 up to 1 decimal. On moon, it's smaller. On Jupiter, is bigger. So you will feel heavier there. But mass, it's amount of matter in material. So mass will stay the same, doesn't matter where you are. So force of gravity or weight will change. So in real life, mass and weight often like the same, but in physics is different. Okay, not to confuse. So mass is m, force of gravity, weight is F. So if free body diagram we are using to show which forces act on the object. So force of gravity equal mg. So you multiply mass of the object in kilogram by acceleration of free fall, 9.8 meter per second squared, and you will get force in newtons. So forces up and down equal and opposite. So object is at rest. Horizontally, if object is moving with constant speed, okay, question number 5, for example, you have constant velocity. Okay, so object is moving, we can't tell in which direction, but it's moving with constant speed. So forces are equal and balanced. If we need to include coefficient of friction, so coefficient of friction depends from surfaces. It could be increased or decreased if you put some lubricant like oil, water, because that's why cars can't stop very fast, especially when it's rain, because it's a smaller force of friction and smaller coefficient of friction, mu. Okay, so coefficient and friction, mu equal ratio between two forces. Okay, but it feels like what is force of friction? Mu multiplied by normal force. Normal force is equal and opposite to force of gravity if no pushing or pulling on the object, because if you will push or pull, yeah, it will be more complicated. Okay, so here we are just not touching object, it's on the surface. So force of gravity equal to normal force. So how to get from here mu? Both sides divided by Fn. Okay, so coefficient of friction shows the ratio between normal force and force of friction. Okay, so mu usually more than 0, like on ice it's close to 0 and close to 1 on asphalt, rubber. Okay, you don't need to memorize those coefficients. Usually they're in a table in a textbook. Okay, so here it's nice examples to show how to get normal force and force of gravity, how to get force of friction. So if you have mass of the object, you can find force of gravity, and force of gravity equal to normal force. So mu is coefficient of friction. So mu multiplied by mass multiplied by acceleration of free fall gives you force of friction, right? So mu multiplied by force of gravity equal force of friction. Okay, so here the same idea. How to get coefficient of friction? Basically, you start from the same steps. So if you have okay, everything is okay?
Yeah.
Okay. So if you have normal force equal to force of gravity. So they had weight of the object. So always pay attention on units. So they don't tell if it's mass or force, but because it's units newtons, so it's force of gravity newtons. So normal force equal and opposite. How to get force of friction? Mu multiplied by normal force, and then rearrange for mu. So both sides divided by force normal. So coefficient of friction 0.15. So always try to check if it makes sense. So should be between 0 and 1. Okay, so if object involves acceleration, yeah, so and why? Because forces are not balanced. One is bigger, one is smaller horizontally. And they're asking to get what is coefficient of friction between two surfaces. Okay, so first step, you need to write second Newton's law, because first Newton's law relates only to motion with constant speed or object at rest. Forces are balanced. So here if they mention about acceleration, it means second Newton's law, forces are not balanced. Which ones? So because it's moving, applied force is bigger than force of friction. If it were vice versa, object couldn't move. So force of friction always should be smaller than applied force, or object will not be able to move. And actually concept about mu kinetic and mu static. Okay, yeah, it's also in chapter 4. So if you're trying, so mu kinetic and mu static, if you're trying to make object to move, you're trying hard, you're pushing, applying so much force, but object is not moving. You still apply force, but you can't overcome force of static friction. So F friction, static. So static, it means at rest, so doesn't let you to move. So static and mu static is bigger than mu kinetic. So to make object to move at the beginning, you need to apply bigger force. So to overcome this frictional force of static friction. But when object started to move, now it's easier because kinetic coefficient of friction is smaller than static. Okay, so here we apply second Newton's law. So bigger force minus smaller force. So applied force minus force of friction equal to ma. How to get force of friction? Okay, so just simple rearrangement. Okay, move it to other side. MA, move to the left side. So whenever you move from one side to another, change sign into opposite. So force of friction will be applied force minus MA. So applied force was given, MA, mass multiplied by acceleration. You plug those values. So force of friction equal 15.18. And always check, okay, so this force 15 approximately newtons, applied force 22 newtons. So makes sense. So bigger force applied, it makes object to move. And how to get coefficient of friction? So rearrange formula for force of friction, it's mu multiplied by normal force. So coefficient of friction equal force of friction divided by normal force. So both sides divided by coefficient near mu. What you don't want to have for your coefficient, get rid of it, do opposite operation. So you had multiplication, so you do opposite operation, you divide. Again, less than 1 makes sense, looks good. Okay, so question number 8, 9, 10 involve kinematics. Actually, only 8 and 10. Okay, so number 8, you have speed of the car that you change right away into meters per second, you divide by 3.6. So kilometers per hour to meters per second, you divide by 3.6. How to remember it? Okay, if you have, for example, speed of the car on the road, so approximately like 72 kilometers per hour, cars are driving. So when you change kilometers into meters, 1 kilometer is 1,000 meters, and 1 hour is 3,600 seconds. Look, 1,000 divided by that amount is 3.6. 72 divided by 3.6 gives you 20 meters per second. So try to think, okay, you're driving on the road, so speed is approximately 20 meters per second. It's regular speed, like 70 kilometers per hour, right? So if you're forgetting, if you multiply or divide by 3.6, so try to think in real situation, so speed on the car of the road, around 70 kilometers per hour, so it's approximately 20 meters per second. How to make them? Divide by 3.6. Okay, and vice versa. If you multiply 20 by 3.6, you will get kilometers per hour. Okay, so in question 8, like you got those files I emailed to, okay, I touched there at the beginning. Okay, so what you have, find coefficient of friction. Okay, so start from the beginning. So it's the only one force that acts on the object, force of friction. Nobody's dragging the car. It's trying to stop. Okay, so vertical forces don't involve motion, so you're not worried about them. So net force is your force of friction. Use Newton's second law. It's mass multiplied by acceleration. And now how to get force of friction? Mu multiplied by that normal force. Okay, here it's net force. And here normal force equal to force of gravity. And force of gravity is mg. Okay, so you have mass multiplied by g. you get force of gravity equal to normal force. How to get acceleration? Okay, so that acceleration we found here below. So using kinematics, object is trying to stop. You have initial, final speed, and distance. So one of the formulas that you can use, that one, rearrange for acceleration, and then you plug that acceleration to get net force. Okay. Okay, so try to go through those questions and check how to do it. But first step, always free body diagram. Okay, so you have mass of the object, you have some force, acceleration. So change your speed into meters per second right away, divide by 3.6. So you need to get coefficient of friction. So similar as question number 8. So at first you need to check. Okay, object accelerates because applied force bigger than force of friction. So how to get force of friction? Rearrange that equation. So applied force minus ma. So applied force was given. Acceleration we can find using kinematics. And now how to get coefficient of friction? So both sides, left and right, you divide by F normal. Okay, so normal force is force of reaction from the surface. Okay. So I will try to make it smaller.